Hey everyone, welcome back. Ready for another deep dive?
Absolutely. Always excited to explore new ideas.
Today we're tackling a topic that's both familiar and maybe a bit intimidating for some, quadratic functions and equations.
Ah, yes, the land of parabolas and formulas.
You got it. And to guide us through this, we've got some textbook excerpts sent in by you, our amazing listeners. So what's the plan for today?
Well, we'll break down those excerpts, making those concepts crystal clear so everyone feels confident tackling them.
Sounds great. We're talking about graphing those parabolas, solving equations by factoring, completing the square, and of course the famous quadratic formula.
I think the quadratic formula often gets a bad rap. It seems scary at first, but it's actually pretty elegant when you understand where it comes from.
Yeah, I remember feeling that way in school. But before we get to the solving part, let's talk about what a quadratic function actually is.
Absolutely. At its heart, a quadratic function is simply a function where the highest power of the variable is 2. And when we graph it, we get that beautiful symmetrical curve, the parabola.
Right, the parabola. We see them everywhere, don't we? Like the arc of a bridge or the path of a ball when you throw it.
Exactly. And understanding those equations helps us understand and even predict those real-world phenomena.
Okay, so we see them everywhere, but how do we actually work with these equations? Those textbook excerpts went into a lot of detail about different methods.
They did. Let's start with factoring. Imagine you're trying to figure out where that ball you threw will hit the ground. That's basically like solving a quadratic equation. And factoring is one way to find those solutions.
Okay, factoring. That's where we break down the equation into simpler expressions, right?
Exactly. And when you factor a quadratic equation, you're actually finding the points where that parabola intersects the x-axis. We call those the roots of the equation, the solutions that make the equation true.
So if I can factor the equation, I can see where the ball hits the ground. That's pretty cool. But what if the equation isn't so easy to factor? The textbook mentions something called completing the square.
Right. Completing the square is a bit more involved, but incredibly useful. Imagine you have a square room, and you want to fit in some oddly shaped furniture.
Okay, I'm picturing it.
You might have to rearrange things, add a piece here, remove a bit there to make it all fit snugly.
I see where you're going with this.
Completing the square is similar. We manipulate the equation, adding terms to both sides until we create a perfect square, something easily solvable.
So we're kind of like rearranging the equation furniture to make it fit a perfect square.
That's a great way to think about it. And here's the cool part. This method, completing the square, is actually how we get the quadratic formula.
Wait, seriously? So completing the square is like the parent of the quadratic formula.
Precisely. Completing the square is a more general technique, and when applied to a generic quadratic equation, boom, out pops the quadratic formula. A one-size-fits-all solution to tackle any quadratic equation you encounter.
Wow. That makes the quadratic formula seem less like magic and more like a clever shortcut.
Exactly. It demystifies it a bit, doesn't it?
It really does. But if we have factoring and completing the square, why bother with the formula at all?
Great question. Sometimes factoring or completing the square can be pretty time-consuming, especially if those coefficients in the equation get messy. The quadratic formula cuts through that complexity. Plug in your coefficients and it gives you the answers directly.
So it's like the ultimate power tool in our quadratic equation toolbox.
Absolutely. And speaking of power, did you know quadratic equations pop up in tons of real-world situations? We talked about throwing a ball, but imagine launching a rocket.
Whoa, that's a bit more intense than my basketball analogy.
The path that rocket takes can also be modeled with a quadratic equation, and by understanding that equation, engineers can predict where that rocket will go and make sure it reaches its target.
That's amazing. I always knew math was important, but didn't realize it was behind things like space exploration.
It's truly everywhere. Take those beautiful suspension bridges, for instance, that graceful curve of the cables. That's a parabola, perfectly described by a quadratic equation.
Oh, wow, I never made that connection.
And even something as everyday as figuring out the biggest garden you can fence in with a certain length of fence, that also uses quadratic equations.
It's like a hidden language that describes so much of the world around us.
I love that. Now that you have the tools to understand and solve these equations, try looking for parabolas and quadratic relationships in your everyday life.
I'm up for the challenge. Who knew quadratics could be so fascinating? Thanks for taking us on this deep dive.
It was my pleasure. Until next time, keep those minds curious.
And keep those textbook excerpts coming. We love to explore them with you. See you all next time.